Hey, how's it guys? Right, so in this tutorial, we'll learn how to analyze images using GPT-4 Vision model in Python. So GPT-4 Vision model is a new model OpenAI released recently to compete with Google's Gemini AI model. Essentially, GPT-4 Vision model is a multimodal model with the capability to analyze images. Now, before diving into the tutorial, I want to quickly cover the pricing. Now, in the pricing page, if we look at GPT-4 Vision Preview model right here, so it's going to be zero point zero 0.01 cents per 1,000 tokens, and it's going to be for the input, which is going to be the prompt, and for the output, which is the response generated by the model itself, it's going to be 0.03 cents per 1,000 tokens. Now, based on the image size or the image resolution, the pricing is going to get prorated based on the resolution. And here we have this vision pricing calculator in which you can use to give you an idea on based on the image resolution, how much the API is going to cost you. Now for this exercise, I'm going to share 4 different examples. For the first example, we'll read an image from the web and use GPT Vision to answer the question based on the image. The second example is going to be analyze the image from a local file. Example number 3 is going to extract the contents. So for example, here I have 4 images. For the third example, we're going to extract the contents from the image itself. In this case, will be this code snippet from the screenshot here. And the last example, we're going to analyze multiple images all together. Now, with that being said, let's get started. But first, make sure that you have an OpenAI account. If not, you can go to openai.com and create an account. And for new users, you get $5 credit to use within 3 months. All right, so let's create an API key by going to platform.openai.com/API-keys. Then want to click on API keys, then click on create new secret key. Now here I'm going to name this as tutorial. Now I'm going to copy this key and I'm going to create an environment variable. So using OpenAI Python SDK, it's going to look at this OpenAI _API _key environment variable first to see if there's any API key available. So here I'm going to paste the API key and save the key and OK. Now, one benefit using the environment variable is that you don't need to manually paste the API key every time when you run a script. And if you are creating an API using Cloud Function or AWS Lambda, then it's beneficial to use an environment variable as well. Now here, let's go ahead and install the OpenAI Python package. So simply pip install OpenAI. Now I'm going to create 4 files. Let's call this demo1.py, demo2.py, demo3.py, demo4.py. Right, so for the first example, we're going to use this image that I took in St. Louis, and this is the Gateway Arch National Park photo. So this is the arch. Now let's go ahead and open the script. Now this one module that I created called utility.py. Let's look at the content of the utility module. Now inside this module, I created 2 functions. The first function is going to encode the image into byte strings. The second function, extract code, is going to extract the code snippets without any other noise. You'll see in a second. All right, so I'm going to put a script and the image side by side. Now from the import statement, I'm going to let me increase the font size. From the import statement from OpenAI, I'm going to import the OpenAI class. Then I'm going to construct my OpenAI object. Now, because we saved the API key as an environment variable, so we don't need to merely provide the API key when we create the OpenAI instance. But if we look at the documentation or the docstring here, one of the parameters is called API key. Just in case if you need to use a temporary API key for some testings or development, then you can use the API key parameter to assign the API key. Now, there are other couples parameters which you can look into it. But to be honest, I don't use any of these parameters very often, except timeout occasionally. All right, so once we create the client object, we can now make the API code to load the image and analyze the image. So we can take the client object .chat .completions .create. Now here we need to specify the model ID. In this case, we're using the GPT4 Vision preview model. And pretty soon it's going to be GPT4 Vision well preview. And to provide the image as a content, so here using the messages parameter, we need to provide a list. Inside the list, we're going to insert a dictionary object. Inside the dictionary object, this is going to be the record that contains the prompt. In this case, will be this right here. What is in this image? So that's my prompt. So a couple of things. So first, we need to define the role, and we need to make sure that we use user to specify that we, the user, is going to be the one who is making the request. Then we need to assign the content key. Now inside content, this is going to be another list. And the reason why this is a list because we can provide multiple images, not just one. Then we need to specify the output type. In this case, will be text. So type text, and here let me put this in a new line to make it more organized. All right, so we have the type as text, and it's going to be the output type. Text is going to be the prompt, and prompt is what you want to do with the image. In this case, I just want the model to describe the image. Then we need to define the source, the image source. So the type is going to be image URL. Then we need to define the URL. In this case, we need to use the image URL key. Then we need to provide the source. Then we need to provide the web address where the image is located. Now here the max tokens is going to be the maximum strings that you can provide based on your prompt length. So right now I'm setting the maximum token to 300. That just means that my prompt cannot exceed this max tokens limit. And once we make the API call, we can go ahead and print the response. Now here I'm going to simply print this portion right here. All right, so let me go ahead and run the script. Now, if we look at the output here, so completion token is going to be the token usage based on the prompt, and prompt token is going to be the output. So for this API code, I use 916 tokens total. Now, because this image is actually quite large, so if I reduce the image resolution, the total tokens consumed will be much lesser. But anyway, let's look at the output. So this is going to be the output from response.choices.message. In general, it can return multiple response, but I don't recommend that just because it can get a bit messy. But if we look at the output, so it's returning us this check completion message object. And content is where the actual response is going to be. Then we have row, which is going to be assistance. Function code is none, and couple other things. Now, finally, based on the content extract, now if we look at the actual output, so this is a description describing the image. But if we want to be more specific, so can you identify the location in the image? And this time I'm going to take out this print statement here, and I'll run the script. Now, based on the way how you define the prompt, so this time I'm asking, can you identify the location in the image? So the image features the Gateway Arch, which is located in St. Louis, Missouri, United States, followed by the detail of the landmark. All right, so that's going to be example one. But once you get past example one and you understand the flow, then everything else is going to be a lot easier. Now let's look at how we can use a local file to do the same thing. All right, so if we go into assets, again, I'm going to use the semi image. All right, so I'm going to paste the code snippet. This time I'm going to import the base64 module to encode the image. Now using the encode image, we're going to convert the image into byte strings. Then I'm going to construct my OpenAI object. I'll name that as client. Then we need to define the image location, encode the image, then make the API call. So the only thing that's different in this case is that instead of providing the URL, we're going to use this format right here. We need to type data, image. So this is the MIME type, semicolon, base64, followed by the byte string. And everything else is going to be the same. Now if I run the script, and we now have the response that is similar to the second prompt that I was doing before. Now for the third example, we're going to extract the code snippet from this image here. So noticing that the resolution is not very good, and I did that on purpose. I just want to show you the capability of how good the engine is being able to analyze the image. Now here, let's go ahead and import the libraries. So in this case, I'm actually going to import the extract code function on top of the encode image function. Then I'm going to construct my OpenAI object, define the file path, encode the image. Then I'm going to specify the prompt. So in the prompt, I'm going to say, can you pass the code snippet in the image? Return only the code as a single string. And by saying that return only the code as a single string, we are eliminating the GPT model to return any unnecessary details. All right, so again, it's very similar to example 2. We are literally doing the same thing, except that for the prompt, we are asking the GPT-4 model to perform a specific task. Now I'll go ahead and run the script. Let me try again. All right, so let's look at the content here. Actually, here let me take out the extract code function so we can see before and after. So basically, the extract code function use regular expression to look at the code snippet definition. In this case, would be Python. Then extract the content in between. All right, so let me go ahead and run the script again. Now let's look at the before first. So here's the before. If you ever used Markdown before, then you know that when you need to insert a code snippet, you need to define the programming language name. In this case, GPT-4, the model is able to figure out it's a Python code snippet. Then the regular expression is going to basically extract the code snippet in between the beginning string and the closing string. That gives us this output right here. So basically just the code itself. That's just another very useful use case in case if you need to extract contents from the image rather than type everything on your own. And it's one of the complaints that I get because I don't tend to share my source code just because I don't have the time, to be honest. Now let's look at the final example, which is to analyze multiple images all together. Right, so in this case, I'm going to define two image paths. So we have Tesla1.jpg, Tesla2.jpg, and this is what the image looks like. So we have two different Teslas side by side. And the image on the left is a Model X, and the image on the right is a Model 3. And to be honest, I haven't run the exercise yet. And let's see what the output is going to be. All right, so for the prompt, I'm going to ask, what are the similarity between the two images? Now remember before I mentioned that the reason why the content value is a list is because we can provide multiple image sources. So here we're defining the prompt. Then we're going to provide the first image followed by the second image. And everything else is going to be the same. All right, so let me go ahead and run the script. Okay, so here's the output. Now, once I want to point out that because I'm providing multiple images, so the token usage is going to double. So here, let's look at the completion token, which is only 190 tokens. But for the prompt tokens, I consume 1,206 tokens. So because I believe that because one of the image has a very low resolution, 640 times 480. So I believe that Tesla2.jpg use a lot less tokens or consume less tokens than the first image, which is a high resolution image. If you combine the two, then it's going to be 1,200 approximately in that range for the prompt token usage. And if we look at the response, so both vehicles appear to be from the same manufacturer, Tesla, and different colors. And one of the key things I want to see is whether if the GPT-4 model can identify the model. And here we have, there are clearly different models within the Tesla lineup. And one is Model 3 or Model S, and the second is an SUV, likely a Model X. All right, so this is going to be all the example I'm going to cover in this tutorial, and hope you guys find this video useful. And if you enjoyed this video, please don't forget to like the video and subscribe to the channel, and I'll see you guys in the next video. Bye bye.